So in this lecture we are going to see how to find out all the candidate keys from a given relation. This is frequently asked question in NET or GATE, maybe or 2 marks or 1 mark. They will give you a relation, they will give you functional dependency on that relation, and they will ask you how many number of candidate keys are present on this relation, 1, 2, 3 or 4, find out, right? Or this can also be asked in a university exam, right? You should know how to find out all the candidate keys, because if you know how to find out candidate keys and what are the candidate keys, then only you can solve the problem of normalization, second normal form, third and BCNF, right? So now this video is in the continuation of previous video, so you must check out the previous video in the side button, then come to this video, right? Because prerequisite of this video is what? You should know what is attribute closure and how to find out it, and what is super key, right? Here I have written attribute closure. We are going to define it, we are going to denote it something like this, within plus power. In power you will write plus, means if x is an attribute, then attribute closure, or you can say closure of this attribute, closure set of x's, you will denote with x plus. It will contain set of attributes determined by x, and x is what? Set of attributes. X may be 1 attribute, 2 attribute, 3 attribute. It is set of attribute, right? And here super key is what? In the context of this closure, super key is what? It is set of attributes whose closure contains all attributes of a given relation, right? Now let us take this example and find out all the candidate keys present in this relation. How to find out? I'll discuss it with a simple trick, right? In the previous video we have discussed with a lengthy process. Fine. Now see, now you will think that I am taking a simple example, right? First we will solve it with simple example, then we will take a complex example, like means functional dependency, maybe AB determines C or ABC determine DC, something like this, right? That thing also we will discuss later. Now first of all take this example. See here attributes are this one, so can I write A, B, C, D, E? This would definitely be a super key. Yes, we know. Or you can find out, for that you can find out closure of this key, and closure would be what? How to find out? Simply you can write down A, B, C, D and E, because of reflexivity property. Each attribute can determine itself, right? And 5 attributes are there, and here also I have 5 attribute in the closure of this set. So I can say that this is what? Super key. This is here x. I told you that x is set of attributes. So now this complete is what? A super key here. Fine. So now obviously I cannot say that this would be candidate key, because candidate key is what? The super key whose proper subset is not a super key. So now you need to find out proper subset of this one and also check that is super key or not. And so for this the proper subset may be around 2 raised to power 5, right? Approximately 2 raised to power. Obviously we are not going to calculate 5 and 1 that will contain the complete one. So 2 raised to power 5 minus 2 you can say, right? That would be a lengthy process. Now simple trick is what? It contains 2 steps. First step is this. First of all, take all the attributes. Definitely that would be super key, right? Now check the dependencies. See, here A can determine B. Means if you have A with you, then definitely you can determine B. And in super key I have A. So can I discard B? Yes. Can I write only A, C, D, E? Because if you have A, using A you can determine A itself, and with the help of this dependency using A you can determine B also. Yes, and C, D, E we already have. So closure of this is also containing all set of attributes, so this is still a super key. Now again check. Now I have A, C, D, E. Can you discard something from this? Check. I have already used this one. D can determine E. Now see, I have D and E both, right? And only D, if you have D then that can determine E. So can I discard E here? Of course, if you have D then D can determine E. So here I can write A, C, D and find out closure of ACD. ACD closure is what? A, C, D. Yes, Using A I can determine B, so definitely B. Using D I can determine E, so definitely I have D, so I can determine E. And ACD closure still having all the attributes, so you can say that this is still super key, right? You have discarded E as well as B. See, this is very important step. You need to take care of this thing, how you can discard any attribute from a super key. Now see, here now, can you discard something from ACD? See, no. A can determine B, I have already discarded B. D can determine E, but I have already discarded E. I cannot discard either A, C or D, because I cannot determine ACD with the help of any functional dependency given here, right? So now this is what a super key, right? Now in this super key, I am not saying that this is a candidate key, right? You need to take care of this thing. Now we have only 3 attributes. Now proper subset of this is what? AC, CD, AD. A, C and D, only 6, right? And here proper subset would be around 30. So rather than checking for 30, it's better to check for 6 only, right? Now you can check closure of, you can check if this, these are super key or not, and for checking this you will find out the closure. If closure of any of these key contains all the attributes, then you can say that would be super key. And if the proper subset of this is super key, any one proper subset, then we cannot say that this would be candidate key. But here when you will check closure of all these, I hope now you can check this, then you will find out that none of these will be super key. And if no proper subset of this is super key, then definitely this would be candidate key. Now I have got one candidate key. I am not saying that it is the only candidate key. Still we need to check this thing. Now here one more term is there, that is prime attributes. Sometimes they can ask you what are prime attributes. Tell me the candidate key, number of candidate key, as well as what are the prime attributes. So prime attributes are those attributes which are part of candidate key. Now here at this point of time, I have only one candidate key, that is ACD, right? So at this point of time, prime attributes are A, C and D, because these attributes are part of candidate key, right? These are making candidate keys, right? So ACD out of these are prime attributes, right? Till now, right? I'm not saying that only prime attributes are ACD. Now you need to check. Now in the previous case also I have taken same example and I have told you that only candidate key is this one, there is no more candidate key. Now how to check this condition, right? So now second step is what? First step is we are going to discard one by one the attributes from a super key, right? Second step is what? Once you got prime attributes, some prime attributes, then check your prime attributes are available on the right hand side of given functional dependencies, right? Check A, C, D. Is A available on the right hand side of functional dependency? Functional dependencies I have only 2, 1 and 2. Right hand side is this one and this one. Right hand side only, not left hand side. But A is not available. C also not available. D also not available, right? So now you can say that in this relation there cannot be more than one candidate key. Only this candidate key is available. You will not find any more candidate key. If no prime attribute is available on the right hand side of the functional dependencies, right? Given functional dependencies are this one, then you can say that now you will not find any candidate key. So now you can say only candidate key available is A, C and D, right? This is, you can say, a short trick. This is very important trick here for the point of view of GATE or NET exam, right? This will save your time. Now let us take that case where the prime attributes will be available on the right hand side. In that case, what you will do? Let us take one more example. So suppose this is a relation given and functional dependencies are these one, right? We'll take one more example also where we will discuss the complex functional dependencies as well, right? Now see, first step is what? Simple. I can say that A, B, C, D. Take all the attributes. Definitely this would be super key, right? Because the closure of this would find out A, B, C and D using reflexivity property. Each attribute can determine itself. And the closure of this is what? Having all the attributes of relation, so that is why this is a super key. Now you need to check, can you discard any attribute from this relation, from this super key, right? Check. Now check the functional dependencies for this. See, A can determine B. If you have A, means you can determine A also as well as B also, right? I have A, so I can discard B here, right? So now A, C and D. Using these three only also I can determine all the attributes. And if you need to check out, then if you want to check out, then you can check the closure of this. In closure I can write down A, C, D. Definitely check out the functional dependencies. A can determine B. Do you have A? Yes, I can determine B. And A, C, A, B, C, D. 4 attributes are there, so this is a super key. Although no need to check the closure, right? After using that trick, you can easily discard B, right? Now see, can you discard any other thing here? See, here you can say A determine B and B determine C. So can I say here A will definitely determine C using transitivity property? Yes. So now if you have A, then you can determine C as well. So here, from here I can discard C, right? Because I have A. So what's the point of writing both A and C? Now A, D. This would definitely be super key because closure of this would be A, D. Using A I can determine B. Using A I can determine C also, right? Now can you discard any other attribute from A, D? See now. I cannot discard A because I can determine A with the help of C. C will determine A. So for discarding A you need C, but you don't have C. So we cannot discard A. Can you discard D? Can you determine D with any attribute? No, I can't determine. So now this is super key. We cannot discard now any more attribute. Now check out the proper subset of AD. Only 2 proper subset are there, A and D. See, I'm not saying that this is definitely a candidate key. This thing you need to take care. Now you find out this is a candidate key or not, right? A and D proper subset are there. Now check, is A and D candidate key or not, individual. Now find out A closure and D closure. A closure is what? Using A I can find out A. Using A I can find out B. And using B I can find out C. C I can find out again A, and A I have already written. But now I have only ABC, I don't have D in this closure. So this is not a super key. Using D I can determine D. Using D I cannot determine anything else, right? So none of this is a super key. So now you can say that AD is candidate key. Definitely, right? Now if you go to one candidate key, now you can say prime attributes are A and D. Prime attribute means those attributes which are part of candidate key. So A and D are now prime attributes. Now it's time to apply the second step. See now, second step was what? Now you need to check. We have got one candidate key, still another candidate keys are available or not, right? Now prime attributes, check the prime attributes are available on the right hand side of the functional dependencies or not. Prime attribute is A. Is it available on the right hand side of any functional dependency? Right hand side is this one, yes, you got. In this functional dependency, A is available to the right hand side of this one. So now it means C can determine A. So now in the candidate key, at the place of A, you can write down C. You can replace this A with C. So here, and this D would be as it is, right? So now this, I'm not saying that this would definitely be a candidate key now, but you can say that this is super key. Sometimes you got that when you replace, suppose I have replaced this A with C and only C can determine all the attributes. So only C would be super key, right? So this cannot be a candidate key, right? So now we cannot say that definitely this is a candidate key. You need to check out still. So proper subset of CD is one is C, one is D. Now check out, is C and D candidate key or not, sorry, super key or not. How to find out? Find out the closure of C and D. Closure of C, you can find out C. Using C you can find out A. Using A I can find out B, right? But now I cannot find out D, right? So this is not super key. Now what about D? Using D I can only find out D. I have already checked this one. So this is also not a super key, right? No need to check out again. So now you can say that this is candidate key. We have got two candidate keys. Now what about prime attributes? One more prime attribute is there, that is C. So you need to add one more prime attribute, that is C, right? Now the prime attributes are A, D, C. Now check these prime attributes are available on the right hand side or not. We have done with A, right? Now check D and C. Is D available? No. Is C available on the right hand side? Yes, here. So now what you can do? B can determine C. So here whatever the candidate key you got previously, there at the place of C you can replace it with B. Now B and D, this is what? Super key. I'm not saying that this is a candidate key. Now proper subset are B and D. Now check out this and this are super key or not. How to check out? Find out the closure. But the closure of this would not contain all the relations, so this would not be super key. You can check out this thing, right? I'm not going to check out here. Now this would definitely be a candidate key. Only after checking these two you can say. If B and D are not super key, then only you can say this would be candidate key. It's not like after replacing this and this you can say this would be a candidate key. No, you need to check out the proper subset. Fine. Now this would be a candidate key, right? Now check again in prime attribute we will add B, because B is also a part of this candidate key, right? Now check A we have done, D is not available on the right hand side, C also done. Now check what about B? Yes, B is available on the right hand side of this functional dependency. So here A can determine B. So here rather than B you can write down A. But now you got simply this one. And we already have this candidate key, right? So now you can say three candidate keys are available in this relation: AD, CD and BD. Because we have got again AD and we have checked for all the attributes. These attributes are available on the right hand side or not, right? Now three candidate keys are present here and prime attributes are A, B, C and D. All four are prime attributes. There is no known prime attribute in this relation. So this is how you can find out all the candidate keys, all the available candidate keys in a given relation. You need to practice it. If you practice 5 or 10 question, 15 question, then within seconds you can find out all the candidate keys, right? It is not a lengthy process, right? Now I want to give you one question and you need to solve that question. So now this is question for you. This is a relation, these are given functional dependencies and you need to find out number of candidate keys and what are those candidate keys, and as well as what are the prime attributes available in this relation, right? And you can tell me in the comment box, right? If you want me to solve this question, then you can tell me in the comment box, as well as I'll make a video on this also and I'll upload it, right? So now I'll see you in the next video. Till then, bye bye, take care.